So in this video we continue looking at the problems on test 4 in fall 2013 of the AP Physics. A stone is thrown vertically upward with a speed of 23 meters per second from the edge of a cliff. The cliff is 75 meters high. Alright, we need to set an origin. You have your choice of where you want to do that. I'm going to put my origin setting around here, so this is y equals 0 meters. And the person's throwing it up here, it says that's y naught. Y naught happens to be 75 meters. So again, like in all these problems, you want to set up a table. Y naught, y, vy naught, vy, ay, and t. Ay is minus g in all these problems. Vy naught is 23 meters per second. Y, I don't know. Vy naught is 75 meters. You're also going to need to put in a set of equations, the kinematic equations, to work the problems. I put this table to start. So the first problem asked me to do what's the maximum height above the ground obtained by the stone. So in this case, Vy, the final is going to be 0 meters per second. This is for part A. It may be different in other parts of the problem. I do not know the time, and I do not know the height. I'm looking for y. So let's solve the problem. In part A, find the height. We have the kinematic equation that the final speed squared is equal to the initial y speed squared plus 2 times the acceleration in y times y minus y naught. We know that the final speed happens to be 0 at the maximum height. So this says that 2ay times y minus y naught is equal to minus vy naught squared. So therefore y minus y naught is minus 2 vy naught, vy naught squared over minus 2g, and the minuses will cancel. And then y is therefore y naught plus vy naught squared over 2g. Putting in some numbers here. We have 75 meters for y naught. Then we have plus, we have 23 meters per second squared, and then divided by 2 times 9.8 meters per second squared. And now we punch that into our calculator, and we come up that y is equal to 75 meters plus 27.0 meters approximately, and so it ends up approximately 102 meters above the ground. Next part. In part B, it asks how long does the stone stay in the air. So this is not a symmetric problem. You cannot take the maximum time to go to the maximum and multiply by 2. What you have to do is to fill out the table based on this problem, part B. So I'm going to fill out a new table. Y naught is equal to 75 meters. Y, the final location, is 0 meters because it's going to be at the ground. The initial V naught is still 23 meters per second. Vy you do not know. You cannot consider it to have hit the ground. If you do, then let me change this. If you do that, then it's not under constant acceleration. Whoops. I just did what I said you couldn't do. It's not under constant acceleration, and so you would not be able to use the kinematic equations. The acceleration in y is minus g, and the time we don't know. We have y is equal to y naught plus v y naught t plus 1/2 ay t squared. That's the kinematic equation. We know that the final location is 0. We could rewrite that equation as minus g over 2 t squared plus v y naught t plus y naught is equal to 0. This can be identified as A, this could be identified as B, and this can be identified as C. And so we have a quadratic equation, at squared plus bt plus c equals 0. And in that form, we can use the quadratic formula. And so we use the quadratic formula. The quadratic formula says that t is equal to minus b plus or minus the square root b squared minus 4ac, all of that over 2a. And we have one additional condition. We have the condition that t has to be greater than 0. So one of these two things here, one of these two roots, is extraneous in this problem. It only is at the ground at one time. Putting in our values for b, a, and c, we get that t is equal to v y naught minus plus the square root v y naught squared plus 2g y naught, all of that over g. And again, that has to be greater than 0. Now looking at that, vy naught's a positive number. This number is going to be even bigger than vy naught. So if you subtract it, you're going to get a negative time. So the negative time, the negative cannot be allowed. That has to be the plus. You can plug in the numbers and you'll find a negative number for time, and that's not accepted. The problem starts at t equals 0. Now all we have to do is to put in the actual values for these quantities. And let me change my pen color back again. So we get t is equal to 23 meters per second plus the square root 23 meters per second squared plus 2 times 9.8 meters per second squared times 75 meters. All of that divided by 9.8 meters per second squared. You punch all of that in and you come up that is 6.91 seconds. So that's how long it's in the air. Part C. Part C says, what is the stone's velocity just before it hits the ground? Alright, so to find the velocity, they're asking us for Vy. Vy is equal to Vy naught minus Gt, since after all Ay is minus G. So Vy is approximately 23 meters per second minus 9.8 meters per second squared times 6.91 seconds. So Vy is approximately minus 44.7 meters per second. This is not the only way that you could work this problem. You could have also worked the problem for Vy squared is Vy naught squared minus 2g y minus y naught, where y happens to be 0. Then Vy would be equal to the negative square root of Vy naught squared plus 2g y naught. Why the negative root? Because it's going down. So that gives the direction. And if you plug that in, you'll still get minus 44.7 meters per second. So get same answer either way, doesn't matter which way you do the problem. And that finishes problem 7. So we'll talk to you again in the next video as we work problem 8.